PID video assignment. What is a PID? Also known as mechanical flow diagram, is a detailed diagram in the process industry which shows the piping and process equipment together with the instrumentation and control devices. Superordinated PID is a process flow diagram (PFD), which indicates the more general flow of plant process and the relationship between the major equipment of a plant facility. Difference between PFD and PND. A PFD shows a fewer details than a PID and is usually the first step in the design process, more appears eye view. The PFD are used in chemical process and engineer. This diagram shows the flow of chemicals and the equipment involved in the process. Then, the PAD include more details than the PFD, include major and minor flows, control loops, and instrumentation are used by the process technicians and instrument and electrical, mechanical, safety, and engineering personnel. The importance of PID is a key role in the maintaining and modifying the process they describe because it's important to demonstrate the physical sequence of equipment and systems, including how these systems connect in terms of processing facilities. Example of PID diagram that shows the main water supply that enters in the tank, the first tank, and this is going to the tank 2, and also there are recycle system. We can see a lot of labels that we are going to explain later.
PIDs give us valuable information about the process diagram, and in this case we can find equipments, pipings, and other instruments that are identifying them in the diagrams. In the first case we have that in the equipment shows spare units, parallel units, and summary details of each unit. For the piping, we have that it also describes the size, the schedule, the materials of construction, and the insulation, which is the thickness and type. And other instruments are identified as indicators, recorders, controllers, and instrument lines. Well, there is a standard that gives us information, additional information that we can easily use to identify instrumentation on PIDs. As we can see in the table, we have first a circle with a different type of lines. That means that an instrument is located in a plant or in front of a panel in control room or are located on the back of the panel in control room. Additional to that information, we have that there's also circles with 2 or 3 letters that are identified as the first letter, which is the variable that they are measuring, and the second or third letter are the characteristic that the variable has. And finally, there's instrument connections identification. There's 3 types of connections, that is capillary, pneumatic, and electrical.
These are the level diagrams that are found in the tank-to-tank diagram, and they're basically divided in flow or level variables. The diagram starts with the main water supply that goes into tank 1, and it has a first valve that goes into the level transmitter and the level relay that changes to an electric signal that goes to a level switch with a level alarm for low and high, and also to a level record. The first tank also has a first circulation pump that goes back again into tank 1, and this has a flow control valve with also connected to a flow transmitter and a flow relay to change this to an electric signal. This flow control valve gives this pneumatic signal to a flow relay and a flow quantity indicators. This also has a flow recorder, the flow switch with its flow alarm level. The first tank also has a second bump, that is the discharge bump. It also has a flow transmitter with a flow element, and it also has a flow relay to change to an electric signal connected to a flow controller indicator, the flow recorder for flow quantity also, and the flow switch connected to the flow alarm level. This signal goes to a second flow control valve that's connected by a pneumatic connection to a flow relay, and this connection finally goes into tank 2. Tank 2 has also connected a level transmitter that's transformed with electric signals to go to the level recorder, and the level switch, which also has a level alarm for low and high. And this tank 2 has a discharge bump that goes again to tank 1. And it also has a flow control valve that is connected to the flow relay and changes the signal to an electrical one. And that's connected to the flow indicator controller, the flow switch with the flow alarm level, another flow recorder, the flow transmitter. It also has a flow transmitter with the flow relay, and it also measures the flow quantity. And this is it has a reach state pump connected to the recirculation of tank 1.